How do we check if this function is one-to-one or onto? How do we even get started? Well, I tell my students the best thing to do is just do some examples and see what happens. I might tell them to think about 4 random inputs and think about where they're going to go as outputs. If we do that, we see that we got lucky and we notice 2 different inputs go to the same output of 0, 0. So right away, we know that the answer to the one-to-one question is going to be no. Now, this won't always happen when you do an example, but very often it will. You'll get some sort of insight about the function. Now, to think about the onto property, we have to be a little bit more careful. What could we get in the first coordinate? Could I get a 6 there? Could I get a -5? And because I can take the cube root of any real number and get a real number, it is possible to get any number in that slot. But we also have to think about the second slot. To be onto, it should mean that any 2 numbers we pick as a potential output actually occurs. So if we have some point in the target, say 6 comma blank, and we're trying to get something that goes to it, I know that that x-coordinate has to be the cube root of 6. But now that we know the x value, the y value over here is going to be the cube root of 6 times whatever y is. And if you think about it, whatever I want over here, I'm going to be able to get by changing my value of y. For instance, if I wanted to get an output of 100, I would just plug in 100 divided by the cube root of 6, and that would work perfectly. And so that shows us that 6 comma anything would indeed be in the range of this function. Does that mean this thing is onto? No, not necessarily. What if we change that 6 to something else? If we change it to any non-zero number, like, I don't know, -5 or -50, we're still going to be able to get everything just as I did before. But there's one special value I always point out is worth thinking about, which is 0. If we have a 0 in our first spot, then the x value must have to be 0 as well. But now, this position over here, 0 times the y value, will always be 0. And so all of our outputs that have a 0 in the first spot have to also have an output of 0 in the second spot. This, for instance, tells us that the output 0, 1 is never achieved, and so this is not in the range of our function. And so that concludes this problem. We see that it's neither one-to-one nor onto.